Buddy, this is a more detailed video of my film scanner. I will do two videos. I will do this one that focuses on the optics and mechanical components, and I will do another video that focuses on all the electronics and software. So to start off, I will talk about the optics. The lens is right here in the middle. It is from a Bosch security camera lens. It is a single lens system because most of the macroscopic lenses that are readily available for security cameras, photography, anything like that are meant to take images of something that is relatively far away from the lens compared to the lens to the sensor. Well, here, as you can see, the lens to object is about the same as lens to image. Therefore, we couldn't use these off-the-shelf lenses that you can buy. To get around this, we just cut off the first lens out of a Bosch security camera lens assembly and left the aperture control, lens distance control, and the lens itself on it. With this, we got the proper focal length, but because it's a single lens system, we now needed to control both the distance from the lens to the sensor as well as the whole assembly to the object. To accomplish this, we have the original lens to sensor control from the assembly, and we have these translation stages here that move the whole assembly forward and back. This one in particular is used for the focus, and it also has a micrometer so you can write down the distance that would give the proper focus. And these two linear translation stages and this rotational stage are used to align the sensor with the film and center the image on the sensor. It was very hard to determine where the active area on the sensor was, so the linear translation stages help solve that, and the rotational stage helps solve the parallelism between this plate and the film. To get a proper image, they have to be very, very parallel, and it just wasn't practical to machine these components to that level of precision. It was much more economical and time efficient to just buy a translation stage, put it on there, and then once everything's machined, it can be aligned, and this only needs to be done the first time, so it's not a big deal. Every scan doesn't need any alignment. Next up is the aperture control. So because the lens is very large compared to the distance from the lens to the object being filmed, the aperture needs to be very small. Otherwise, the depth of field is very, very tight, and it's less than a micron. So the bow of the film actually makes the sides become blurry, or the middle be blurry and the outsides be in focus. So to solve this, we tightened the aperture. Right now it has a 1/8 inch aperture opening. I'm going to try to get a better view of it here. The original aperture control for this lens was just a shutter. So if you closed it to this level, it would just be a slit you're looking through. And this created image artifacts. And we needed to get something around and better and closer to the lens. So I machined this plastic piece here. It's just a plastic cylinder with a 1/8 inch opening. The opening is very thin as well, so it creates less artifacts, and that seemed to do the trick. Without this, it was just not possible to get the image quality, and even with the original aperture control, it would just create a lot of lens artifacts, and it would be like filming the sun. There would just be lens artifacts everywhere. For the mechanical side, I'll start with the feed reel. So it's up here, fairly simple. There's just a clip you can remove the film with. There's an adapter in the middle, so it can take both regular 8 and Super 8 film. This goes in here, clips down or up to lock it in place. After that, it goes into this aluminum plate. Get it into focus. Yep. It goes into this aluminum plate, and there's some felt cleaners to get any dust off of it. We clean all the film before scanning anyway, but there's always some dust that collects as it's moving through. This helps get rid of it. Past that, it goes into the film holder. This is out of an older projector. It was slightly modified to give a wider shroud for the film, and I just milled it out. Nothing too fancy about it. This is a critical component to get the film properly scanned. The precision on this piece needs to be within 10 microns, or 4 thousandths of an inch. And just overall, it was very difficult to machine this piece properly. I was lucky enough to find it out of an old projector and put it on there. They solved the precision issue by just having springs push on the film, so I doubt they were machined it to accurate precision. And this is 4 thousandths of an inch total, so it's plus or minus 2 thousandths, and it was very difficult on the equipment I had. With these springs, they can be off by more than that. The springs will align the film in the center properly. It's a very elegant solution they had. And there's also these springs here, I don't know how visible they are, that put tension on the film. So if you put too much tension on or pressure on the film, if you put too much pressure on the film, you can't move it through, and then it will break or get stuck. If you don't put enough pressure on it, you will get the film bowing, like I talked about earlier, past the point that you can reasonably scan it. So the people designing the projector solved this by putting these springs that apply the proper tension on the film. When I got this component, I machined this aluminum piece here to the same dimensions as the one on the projector. So this gave the proper pressure on the film and let it slide through while still keeping it nice and straight. Past this, all of the very, very tight tolerance pieces are done. It just has a roller down here and another roller up here. It's just 8mm precision ground stock. Put a reamer through these aluminum pieces, and I used some rollers from a old printer to help guide the film through. The rollers need these raised sides to function properly. Without these raised sides, the film will want to run up the wall. With these raised sides, accelerate the side of the film that it's touching and push the film into the middle. This was very critical, otherwise when the film starts riding up the wall, it just creates too much resistance and you can't pull it through by any reasonable amount of force. Back here is also the LED. This is more of an electronics component, but I can talk about it right now since it's right here. It's just one of those little LED plates that they sell them for LCD displays, whatever. It's just a little LED plate, and an aluminum holder, and then there's a diffuser and a reflective piece of plastic from an old TFT monitor. I just took the diffuser off the panel after this aluminum piece, the diffuser, and then it goes into the film. So back here is the capstan motor. It is, and the capstan roller. It is the only motor that was precise enough to pull the film through. Since we're scanning in 1080p, each pixel is only 8 microns on the film. So to reach near pixel precision, it needs to be able to move by very, very small steps. To do this, we use the capstan motor out of an old VCR and then apply the pulse width modulated signal to it from the electronics board. You can see it moving, stepping through it slowly. So with the pulse width modulation, we're able to have very, very small movements, and when the electronics detect the proper position of the film, they shut off the motor stops, and we're able to scan the film. For the capstan roller, it's just a spring and an aluminum piece holding a roller over here. It's not very visible. Blurry, can't get a good image, but there's some tires down here from model aircraft, and then I machined a brass rim for them that hold both tires, and then the tires drive the film through, and the capstan motor drives the tires. They're just very firm springs down here. I do need to replace these. I used springs that were a little too weak and I overstressed them. But just in general, there's just springs here. There's an axle down here, and then springs right here going in the middle, pushing this lever up and putting pressure on the film, helping it push through. Past that, there's another roller down here, and then it goes into this up here. We have the uptake reel. The uptake reel has a small DC motor in the bottom. This screw here just holds a spring tension for the locking mechanism. The DC motor drives this large gear. This large gear gives it enough torque to move this large mass. It also slows it down. These small motors move very, very quickly, so this wouldn't be appropriate for an uptake reel, especially that we're scanning it only frame by frame. Over here we have the locking mechanism, just like in the front. Just pops in place, holds the reel in. Behind the reel we have the drive insert. It is this hexagonal piece over here. It has protrusions to fit the holes on the reel, just like in a regular projector. The step is so it can both interface with regular 8 and Super 8 reels, and there is also an adapter on it for the different hub diameters for the two standards. So to load it, just put it on the reel and off it goes. Just lock it in place. That's it for the mechanical parts. Thanks for watching.